dividing by one-digit numbers. For an example of a harder division problem, let's use this problem. There are 152 cans of food to be given to 4 needy families. If volunteers wanted each family to have an equal number of cans, how many cans of food should each family receive? This problem could be a very cumbersome problem if we had to stack up 152 cans of food around this table and then one by one divide them into 4 piles. I think we know that we have a better way to do this now by using division. So we're going to use this as a long division property problem. Let's start with 152 cans of food. We want to divide this into 4 equal portions for the families. So we can write 152 divided by 4. Or we can use our alternate form of writing a division problem so that we have 152 divided by 4, or 4 going into 152. This is a much more challenging problem, but you have all the skills that you need to solve this problem. What you want to do is check with the divisor and see how many times it goes into the first number of the dividend. If I look at 4, I can't think of a number that when I multiply it, it will give me 1. 4 does not go into 1 evenly. The next thing I need to do then is to check for 2 digits of the dividend. So I want to see if I can make 4 go into 15 in a very close manner. Now I want to come very close to it, but I don't want to go over this amount. I want 4 times something to be very close to 15 without going over, sort of like the Price is Right. If I think of a number that I multiply by 4 to get something close to 15, I might think 4. Now you'll notice when I put my answer up here, I align it carefully over the last number in this pair. It's important that you keep your numbers aligned in division, otherwise you can lead to sloppiness and that can cause greater problems later on. I'm going to multiply my quotient times my divisor, and when I go 4 times 4, I get 16. Right away I notice 16 is too much because it's more than 15. So I'm going to take this number out and I'm going to try for a little bit smaller number. Remember, I want a number that comes close but does not go over. I'm going to try a 3. When I do the multiplication, 3 times 4 is 12. So now what I need to do is remember that I've taken the quotient times the divisor and I've written it down, once again aligning the columns carefully. The next step in the division problem is to subtract this amount from the 15. So in the ones column, 5 minus 2 is 3, and 1 minus 1 is 0. The next step in the division problem is to bring down another number. I'm going to take this number and just slide it down in its column so it's carefully aligned with the 3. So the 2 will just slide carefully down, and I will have a 32 down here. I'm going to do a new division problem, and that is the problem of 4 into 32. In other words, I'm trying to think of a number that when I multiply it times 4, I'll get very close to 32 without going over. 4 times some number is very close to 32, and that number is 8. Now the next step is to multiply, so I'll take 8 times 4 is 32. And you'll notice the step here was to subtract. The step here is to subtract as well. We're following the same set of steps in order. When I subtract from the ones column, 2 minus 2 is 0, and 3 minus 3 is 0 as well. I have no more numbers to bring down, so I know my division problem is complete. I started with 152 cans of food. I divided them equally for 4 families, which gave 38 cans of food for each family. Now remember, when you're doing a division problem, you should always check your work. And your work should be checked by doing the reverse operation, multiplication. So I'm going to say I have 38 cans of food for each of 4 families. 38 cans of food for 4 families. When I multiply this, I'm going to take 4 times 8, which is 32, and carry the 3. 4 times 3 is 12, plus 3 is 15. So if each of 4 families was to get 38 cans of food, we would need 152 cans of food in all. And sure enough, 152 cans of food is exactly what I started with. So I know that 4 goes into 152 38 times, and each family will get 38 cans of food.
This plywood measures 48 inches. These joists are to be put on center. Divide this 48 into 3, and it will give you the center distances for these joists. Before we do the math, I like to draw this on the board here. This is the plywood that is 48 inches wide. That's over here. So this is 48 inches. And the joist on this plywood is, and it extends right in the middle over here. There's a joist on either end. And then there's two more. And there's 1, 2, 3 spaces. And so what we want to find out is the center distance between these joists. What is that distance? These x's between here and between here and here. So what we have to do then is divide 48 inches by 3. So let's do that. So 48 divided by 3 equals, how many 3's go into 4? 1 minus 3 is 1. Bring down the 8. How many 3's go into 18? Is 6. So 3 divided into 48 inches equals 16 inches. So between each joist is 16 inches. Now this could be a piece of plywood or it could be a piece of sheetrock. And you find that when you're attaching plywood or sheetrock, you attach it with a nail that are put in that to go into these wooden joists. And they have a very interesting device. It's called a stud finder. And notice this red pointer on here, there's a magnet at the end, and this is a steel nail. And what they do then, you just go over it, and watch what happens to the pointer. You notice how it moves? And so all you have to do is take this stud finder, there's others on the market, this is just a cheap one, and you can go over the wall and try to find a nail. And once you find a nail, then you know along that whole joist, you can nail something. And so, and when you find one, you generally can find all the others because usually the joists are separated equally. And if it's 16-inch centers, you can just keep on going down the wall, and as long as you find one and you'll find that other joist, and you can, again, if you want to make sure, use a stud finder to make sure. So, with the plywood or the sheetrock, it's 48 inches wide and 3 equal spaces. The spacing is 16 inches. The man is pulling in a marlin from the back of a fishing boat. Say the marlin weighs 148 pounds. The man with the current pulley system has to pull the full weight of the fish. If he had a 2-to-1 pulley, how much weight would the man be pulling? Let's do the math. Before we do the problem, I'd like to explain a little bit about the pulley system. Right here we have a single pulley. All right, if you put a weight on here, say this weight is 100 pounds, and you pull here 10 feet, this side will also go 10 feet, and it's 1-to-1. This is a stationary pulley now. So this will rotate, and when you're pulling here, you also will pull here 100 pounds. What this would be, we'd say a 1-to-1 pulley, 1-to-1. Whatever you pull here is what you're pulling up over here. This is 1-to-1. Now this is a 2-to-1 pulley. Now this is fixed. This is hooked over here. This will not move. This pulley goes up or down, depending what you're doing over here. All right, now say this pulley has the same weight over here. That has 100 pounds. Now we're going to still move 10 feet. Now we're going to move 10 feet over here. Now if you pull this 10 feet, this is fixed up here. This is going to go up now. But this is only, if you pull this 10 feet, 5 feet moves over on this side and 5 feet over here. So it's half the amount. If you pull 10 feet, this will go up 5 feet. So because of that then, instead of you pulling 100 pounds, you pull only 50 pounds, half as much. So you divide this 100 by 2 to get 50 pounds. So that's a 2-to-1 pulley. This is fixed. This is fixed. This pulley is fixed. This one moves up and down. When you pull here, this will go up. So let's do the one with the marlin. So the marlin weighs 178 pounds. And we've got to divide that by 2. 2 goes into 17 8 times. 1 left over. 2 goes into 18, 9. So you'll be pulling on a 2-stage pulley. You'll be pulling 89 pounds.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.